back. Okay. So here, in the same way, guys, set of all strings of length 3, if power sigma power 3, what will be the possible strings over here with the length 3? These are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, and triple 1 and 1, 1, 0. Right? So can you, so in this positive closure that we have discussed earlier is what? Power 1 union power 2, sigma power 2 union power, sigma power 3 till infinity. And what about the star closure? Here it includes the null set power 0, that is string of length 0. That is the difference. That's what. Okay. Now can anybody, if they understood this thing, can you people tell me how to find out the number of strings possible? How to find the number of strings possible for this sigma 0, sigma 1, sigma 2, or that sigma power 2, sigma power 3? Is there any formula that you may be getting with this? Is it any formula? So if I say sigma to the power 1, matlab, yeah, it is आ जाएगा 0 1 तो 2 sigma power 2 it means there will be 4 sigma power 3 it means 8 1 2 3 4 5 6 7 8 8 sigma power 0 is 1 one string is possible. So can you able to tell me how you are going to find out how many number of strings can be possible? Can you generate a simple formula to explain this?
2 raised to n.
2
Very
raised
good.
to n.
Very good. It is 2 raised to n. Very nice. It is 2 raised to power n. You can find this question in some examination, computer examination. You will find it. Okay. So this is how the power we have discussed about this thing. So I am explaining through the example. Next, I'll explain the Chomsky hierarchy in the coming days, not now. Okay. So I'll directly come to the finite state machine now. So what is a finite state machine? Okay, a finite state machine for program modeling, how we are going to model a program. uh, the important concept what in by state, finite we are aware of, machine we are aware of, what in by state we'll be discussing about this. Where it is going to apply, it is going to apply for the circuit controls, embedded control, maybe machine for recognition, and we'll be designing for finite state machine. Actually it has the four very important things. These are your states, these are your states, state transition. Here are the certain rules, nothing but we are transition functions, it is also called as a transition function, and input events. Now what is this input events, what are the state transition? We'll be discussing all those things in today's class. Before this, I don't know whether I have explained this to you people or not. Did I explain this class?
No, sir.
Okay, fine. So let us assume how it is been useful, how to draw all those things. I'll be explaining over here. Now let us assume you have a C program. And this is familiar for you, right? I equals to 5, j equals to 6, and k equals to 0. Let us assume they are initialized with the int variable, int I, j, and k. Okay. Now I'm doing k equals to I plus j, and here is one decision making statement. If else statement I'm using. If k is greater than 0, I becomes 0, else j becomes 0. Okay, we are already aware of. I now I'll explain how this is been actually done in the memory. Now the problem is whether this can be modeled with FSM. The answer is we'll be seeing in a couple of slides. Now what happens if the first line, the compiler reads the first line. So in the memory what happens, the memories are created as int I, j, and k is been initialized. Okay, so the I equals to 5, you can see this is what I is initialized with 5, this is j, k, j equals to 6, and k is initialized with 0. Now when it, and this is the CPU which does the computation part. Okay, now once it reads the second line k equals to I plus j, now what happens, it gets the value of I. What is the value of I? 5. What is the value of j? 6. So it does the computation, and where it has to store in the k. Where is the k value? Here it is. So the 6 plus 5 is been stored as 11. Earlier it was 0, now it is been updated as a 11. Okay. Now here is the computation part. Now what we are doing, if we have read this line, if k equals to k greater than 0, I equals to 0. What was the k's value? K is holding 11. K is holding 11, and now I value becomes 0 because the condition is true. Else, now if I execute the say, consider this, else j equals to 0. So for timing, let's assume it is making j value becomes 0. Now what actually it happens, please try to consider, because I'm going to represent this program for the modeling way, how it is. See, this is the 1, 2, 4, as well as there is one 3 level structure also. 3 state is also there. Okay. So these are generally these circulars are called as the states. These are the states 1, 2, 4, and here it is 3. Okay. Now what happens here? Okay. What happens here in the first state? In the first state, when the I and j values are initialized, I and j values are initialized. In the second state, what happens? K is being computed as I plus j. Now here is the computation. If k greater than 0, perform something. If k is less than 0, perform something. Right? So this is what the complete program, what we have done is nothing but your finite state machine. What finite state machine has? Finite state machine has these states. These are called as the states 1, 2, 3, 4. These are called as a transition. Transition means moving from one place to another. Okay, moving from one place to another. That is the medium we are going to call as transition. Transit from one place to the another. So over what? Over, these are called as their alphabets, or because over alphabets it is going to transit from one place to another. Okay, so this is a transition, this is a states, and other related terms will be seeing one by one. Now this is what your flow chart, if you are aware of all those things. Okay, so if you able to see, you will feel okay, this is nothing but look like your flow chart, and this is what your finite state machine. Isn't it simple? We are going to design all those things. So if for any program, if I wanted to write, we can design FSM if we are able to get the flow chart, right? So in the first couple of slides only I mentioned, what is a program? It is nothing but an algorithm plus FSM. You require this thing logic. Okay, so that's what is the theoretical concept. Before writing, before implementing any program, you should get the knowledge about this. Okay, so finite state machine, we have already said how it is going to be used. Now I'll come and very important point about the, this is also called as a deterministic finite automata. Deterministic finite automata. Okay, plus this is called as a DFA. I will put it here, deterministic finite automata. Now this is what will be uh, targeting for today. Okay. Now, what is the definition of a deterministic finite automata? This is very important. It gives you 2 marks, and this is very crucial to understand the DFA, because from today's class onwards, we'll be designing the automata, and to understand that we should know the basic knowledge about this. So, it is nothing but it is a 5 tuple machine. Okay. So, what are those tuples? So, you can see here Q. This is your sigma, then this is something what you used to call this, isn't it a delta?
Yeah, yes. Yes, sir.
Yeah, it is a delta. What is that? I'll explain. This is q0 and this is f. Now where this is very important, this is a representation of DFA. When I'll tell about the DFA, you should represent the DFA in these 5 tuples. Okay, these are the 5 tuples. Now what is the q in this? Q is a finite set of states which we have seen here. These what I have said about this, these are the states. Okay, without state, finite state machine cannot be drawn. Okay, so this is what the state. So q is represented about the finite number of states, finite set of states. How many it is a set of states. This is, I think it is you people are aware of this, that is sigma nothing but the alphabets. This alphabet, we are doing the transition is what, from one state to the another state we will be moving over the sigma, over the alphabet. How it is, we will be explaining. Okay, next, this is a transition function delta. What you are saying on delta, this is our transition function. Now what is my transition function which is applied over the transition. You know that there will be a transition, so the a function is nothing but, we can say, set of rules which has to be applied to perform the transition. Okay, then this is a q0. Q0 is initial state. Initial, there will be a lot of the states. Okay, so out of that we will be interested in two things. Actually, there are the three things in the total states. Which one is the initial state? The state from which your processing will start. Initialize. Okay, the starting state, initial state. Generally, the starting state, initial state, we are representing with Q0. Okay, and there are the final states. So this F, what here we have, this is a final state. Okay, so initial state, final state, as well as their non-final state. Three states are there: initial, final, and non-final states. Okay, so this sigma is a set of symbols called as alphabet. This is a transition function, and now this is very important. This gives you the differentiation between deterministic finite automata and non-deterministic finite automata. This is a transition function. What it tells, states over alphabet gives rise to new state. How we are going to represent, how we are going to read in set theory like this. Transition function is, it is a set of states over alphabet leads to some other state, isn't it? So this is very important. Set of states, a state over alphabet gives to maybe some other state or the same state, right? So Q0 is the start state, and Q0 belongs to set of states. In the same way, F is a final state, and it also belongs to Q, that is, which is a set of states. It is also called as accept states. Class, I'll take the first example over here, on-off switch automation. Now please try to understand what I'll be doing here. On and off switch. What I explain here, if you do not understand, don't worry. I'll be explaining all those concepts with this example. Now, you know, on and off switch, two-way switch. Yeah. What actually happens here? क्या करते हो आप लोग? I need answer. There will be, say, a two-way switch, on-off switch, right? So if I put, say, if it is on, and if I press that button, what it happens, guys? See, simply there is a one machine, or there is a one button जो लिफ्ट में या फिर आप देखते हो उसे पुश करना होता है बटन को. ओके, सो ऑन एंड ऑफ स्विच अगर फिलहाल ऑफ पे है, लेट अस अज्यूम इफ इट इज इन ऑफ स्टेट, if I press that button, if I push that button, what is going to happen?
It goes to on state.
It goes to on state. Very good. And let us assume if it is on, and if I again press it, what is going to happen?
It goes to off state.
Very good. That was I was expecting. So on and off, basically these are considered it as a states. It may be on or it may be off. These are the states. Now what is the alphabet over here? What transition? Because it will be moving from on to off state over what alphabet? Over what input? That is your pressing the button or pushing the button, right? So please try to understand, this is what your automaton that you are going to see. If I have a button switch which is an on state, these are generally the states are represented with the circle. States are represented with the circle. Okay, if it is on and if I push the button, definitely, as the student has said, it moves to the off state, isn't it? And if it is off and I again push it, it is going to be on. Yes or no, guys? Yeah. And the initial state is, it is what the initial state. If it is on, push off. If it is off, push. If you are pushing it, it goes to on. This is what the first automata you people have drawn it. Any doubts, guys? Please tell me if you have any doubts.
No, sir.
There is no doubt. Okay. Let me see people who are there. So nobody is here. Fine. Okay. Okay. Now let's move with the some other portion. So I hope you understood these states. These are called as the states. Okay. These are called as transition, and this is what the alphabet. Now what happens, as I have written here the functions as the transition function. I'll just copy this. Okay, I have written the transition function as, I'll just put it here. I'll simply transition state. Okay, state on. What is the alphabet it has? Over push. Where it goes? Off. Is it the different state? Hope you are understanding the transition function. What is the transition function? It is saying from one state over one alphabet, from one state over one alphabet, it may leads to the some other state or itself. Okay, it leads to maybe different state or same state. Okay, so this is what happens over on state, over the push. When I enter, when I press the push button, when I push the button, it moves to some different state. Yes, this is what the transition function. I'll move to the, let us guys try to understand this first program. This is what so please you may take the pen and pencil or a paper and a pen, and I need answer from you people if you understand this. This is example one for the domestic finite automata. Design an automata which accepts only odd number of ones in the set of 1 and 0. In the set of 1 and 0. Basically, when you start such designing of such programs, two things are very important. First, getting or to know the alphabets and the possible strings which can be accepted by the said language. What has been said? It has been said only odd number of ones in a set of 1 and 0 should be accepted. Should be accepted. So what is the number of what all the alphabets it has? Can you tell me? What is the given information? Alphabets, students.
1 and 0.
Yeah, the given information is alphabet. We have got 1 and 0. Now, by understanding these, can you tell me certain some of the strings which can be accepted by this language? What is this problem statement is saying? It should accept only odd number of ones in a set of 1 and 0. There will be a lot of strings can be possible with 1 and 0. Yes, so it should accept only the strings which has only odd number of ones in this. Can you tell me some of the strings which are possible that can be accepted by the automata? See guys, it is saying only odd number of ones. If I sing whether if I make the substring 1, whether 1 is possible from this and whether it is odd number of ones. Yeah, it is only 1 1. Can I say 0 1? It is also possible. You should get the star closer. When I say about to form this, you should always you should always think about the star closure. So these are the strings or substring from this. Okay, what are these? This is nothing but all possible strings, including epsilon. Clean star closure, including epsilon. So all the possible strings, out of that, which all strings which all the strings following the problem statement. What is said? Odd number of ones in the set of 1 and 0. So 1, if length 1, 0 cannot be coming because there is zero number of ones. If I consider 0 1, yeah, it has 1 1, so it will be accepted. What about triple one? It will be having 3 number of ones. It is odd, right? What about double one, guys? Why I have not written double one here?
It is even.
It is even,
It is
right?
even.
It is even. It cannot be. It should not accept by this my automaton. What about 0 0? If I would have written here 0 0. 0 0 is possible. It is a subset of this star closure, right? So I have not written this. In 0 0 string, there is a zero number of one, and 0 is not at all an odd number, right? We require minimum odd number is 1. So in this fashion, if you are able to see 0 1 0, it has one number of 1. 1 0 0, again it has only 1. 0 0 1, and lot of the things. Okay, how we are going to draw this? Now please try to understand, and then directly go with this. First, whether you understood this. This is a given information. Whether you understood any doubts in that, please tell me, guys. Any doubts?
No, sir.
Okay, thank you. Please try to understand now. This is what I'll be doing. You may not understand this directly. I'll use now Jamboard to understand the problem. I am using. I hope the screen is being shared and you are able to see. I hope it is loaded. Yeah. Okay. Okay, class. I hope this is visible to everybody. This is Jamboard. It is a board where we can interactively share this board and we can interactively solve the problems as we do in a classroom board. Okay. So now what we understood with this, I'll take one pen. Okay, pen black is fine. We know we have this sigma. We know we have these states. Okay, generally the states are represented with circles. These are represented with the circles. Okay, now in this also, how to represent, as I said, there are the in the set of states, there are the three kinds of states. One is your initial state, or basically the non-final state. Non-final states are simply represented with the circle. I will write here non-final state. Please excuse me about my drawing skill. Manage with this. It is very difficult to access this whiteboard over here. Okay, so non-final or any kind of states will be represented with the circle. The initial state, non-final state, the initial state is represented with the circle, but and the final state. We have a three states. Okay, this is a non-final state. This is I'll come up with the initial state, and let us assume this is my final state. Now how, if you are able to see, all the states are represented with the circle. Non-final, find no issues. Initial state is to be represented like this. Okay, it is an arrow, inward arrow for the state. It is an inward arrow. See, for non-final state there is no inward arrow. For initial state it should have an inward arrow उसके तरफ आने वाला. There is no transition over this. There is no transition over this. No transition. For final state are represented with the double circle. With double circle. Non-final states are represented with the single circle. Initial state is also represented with a single circle, but with inward arrow. With inward arrow. Final state is represented with two circles. Okay, two circles. These are the basic. You should understand the differences of these states. Okay, non-final state, final state, initial state. That's it. Okay. Now I'll take up to some different. Okay, I'll take another copy where it is. Okay, fine. It was here somewhere. Clear the frame. Yeah. Fine class. Now, what is saying? We understood what are the possible strings drawn. So what we'll do? We first out of this. Where is the problem? Yeah. Out of this, we first draw for the one. One should be accepted. Now what I'll do, I'll just first draw the two states. So draw one state. I'll name it as a Q0. As it is my initial state, we know we are going to represent an inward arrow to represent, to mention it as an initial state. Yes. Now what I'll be doing, I want to accept it. One should be accepted. So what I'll be doing, I'll be creating another state. Okay, let it name as Q1. Okay, kindly consider as a circle. Q1. Now it should be reaching to, and this is one transition over 1. So Q0 over 1 reaching to the Q1, and it should be accepted. If any string is accepted, it means it should reach to the final state. And how we are going to represent the final state? Using the double circle. Okay. Now, one and very important. Whether one is accepted in my what is been asked, one should be accepted. Now, if I traverse one, I think it is reaching to the final state. See at the last, what we are going to do. If all the possible strings over here, it should accept to the final, it should reach to the final state, because if it is reaching to the final state, definitely it is going to be accepted. I want to design that automata which accepts in the sense it should reach to the final states. Okay, which only add number of ones. So one is accepted. What about 0 1, guys? And one thing I must tell you, for every set of states, for every state, what are the alphabets I have in this? I have the 2 number of alphabets. Which are they? Those are 0 and 1. Now, in the deterministic finite automata, for every set of state, for every state, there should be transition on each and every alphabet. This is a very important statement that I made now. For every state, there should be a transition over each and every alphabet. How many alphabets I have? I have 2 alphabets, zeros and ones. Now what I'll be doing, I have the transition over 1. What about the transition over 0? It should have a transition over 0, right? Now, my question is whether 0 1 should be accepted, right? Now, where it should be the transition over 0? Okay, so can I make like this? Guys, try to understand. If I make the transition of 0 like this, okay. Now, if my string is 0 1, whether it is accepted, can you able to see? Q0, because it always starts from the Q0, which cannot start, the transition cannot start from Q1, because we have given this is what the initial state. So Q0 over 0, it is going to Q0. Then for 1, if you are reading 1, it is moving to the final state. And if you see, Q0 has given both the transition over 0 as well as 1. Okay, now it's time to understand with this. What about 1 1? If my string is 1 1, whether it should be accepted or rejected, guys? Tell me about it.
Rejected.
Rejected. Now, for if I start, if I do like this, q0 over,
It should be rejected.
sorry, not audible, q0 over 1, where it reach, where it is going to meet. If I'm going to process this string 1 1, q0 over 1, where it goes?
Final state Q1.
q1. This is what my transition, this is my transition function. State state over alphabet reaching to a state, right? Transition function. So q0 over 1, it is reaching to 1. Now if I reach to the 1, and if I want another one, because I have a 2 1 in my string, where it should reach? It should not go to the, it should not go to the q1, because it is a final state. It will be accepting, and which actually it should not accept. 1 1 should not accept it, right? Then where I should give the transition of this to the non-final state? What is non-final state we have here? q0. It should not be q1, because if it is a q1, it will be accepted here, right? So what I'll be doing, I'll simply give the transition to q0 over 1, over 1. Okay, just try to understand. So one transition, the transition of over 1 alphabet we have given. What about 1 0, whether it should be accepted? Whether 1 0 should be accepted?
Yes, sir.
1 0 should be accepted, in the sense, if I traverse, see, the first, always the first character you have to read first. So where it will be read, it will be read through initial state. So q0 over 1, where it goes, as we have designed the automata, it reaches to q1. Now the second character will be read at q1. Second character will be read at q1. q1 over, what is the second character that I'm going to read? It is 0. Now if it is reaching to the final, if it has to be accepted, if it has to be accepted, it should reach to the q1 itself. Then how we are going to give the transition? It should be like this, guys. It should be like this over the transition 0. Yeah, and if you are able to see q0 over 0 and 1, so what was the deterministic automata? It says, it was saying for every state there should be the transition on each and every alphabet. I had 2 alphabets, so there is a 2 transition, unique transition, I must say unique word. There is a unique transition over q0. See, q0 over 0 and 1. For q1, again there is a 2 transition, unique transition over 0 and 1. It means we are done with our program. Here there is an initial state, there is a non-final state, final state. Okay, now if I ask you, just try to understand the other states, other strings, what you have said about the other strings. Okay, I'll just write down. Can you tell me another, any string which will be accepted by the automata, which should be accepted by the automata? Odd number of ones. कितना भी बड़ा string बताइए आप मुझे. Odd number of ones.
1 1 1.
1 1 1. या बेटा बस इतना ही, 0 0 लगा दो अभी और. Say 0 1 0 1. Is it fine? How many number of ones are here? 5. So whether it should be accepted as per the problem statement we have made, right? Now please try to understand. Yeah. Now we'll see whether it is correct or wrong. Okay. So try to understand. I always start from the q0. So I'll read first one. Okay. I'll read the first one. q0 over 1. Where it goes? Where it goes?
Q1.
q1. Now here from this q1 it reads the second character. So the next one, q1 over 1, where it goes? q0. Okay.
Q0.
Now from this q0 we are reading the third one, that is third character, that is 1, where it goes q1, right? Now we are at the q1. From this q1 we are reading 0, where it goes is it goes to itself, it is at q1 only. Then we are going to read another one, so q1 over 1, where it goes, it goes to q0. From q0 we are reading q0 only, where it goes to itself, I think, right? q0. And from q0 over 1, where you will be going to,
Q1.
is it a final state? Is
Yes,
it a
sir.
final state? So whether the string is accepted? Yes, it is accepted, right guys? Because if any string after processing completely, if it reaches to the final state, it is going to be accepted. If I say, let us assume if I have another one over here, so from q1 to 1 it will be non-final state, because the state the string was even number of ones, so it should not accept. Whether it is accepting, it will not accept. I hope you are understanding. Okay, let me tell you how one example I have taken over here. Let us once again recall. I have taken this program over here. Yeah. See what we have done. This was our automata. These are the general transition. These are the transition. Okay, these are my final state. These two are my final state. What I have done, I was getting initial string which I have to find out whether it is going to be accepted. These are my final states. So when it reads the first character over 0, where it goes, it was going to itself. Okay, now it is left with the triple one, the one transition it will read, it goes to the another state. Now it reads the another one, where it goes to the another state. Now it reads the one, where it goes, it is going to itself. And this is the final state. I couldn't represent it with the double circle, but I have made its color change little bit. Okay, so this is a final state and the string is accepted. Okay, this is what we have done. And finally we have got the program output like this. uh, we have got the output in this fashion. Okay, so from q0, and this is q1, I'm representing with the final state. q0 over 0, it goes to q0. q0 over 1, it reaching to the q1. Okay, this is q1. q1 over 0, it is going to q1. q1 over 1, it is going to q0. And this is my complete automata. It is not only restricted with these many strings. You take any string which follows the language, it should be accepted. It should be accepted. I have another questions for you people, which is saying design an automata which accepts only even number of ones in a set of 1 and 0. Here the question was odd number of ones. I'm asking even number of ones. This is an exam. This is an homework for you people. There are another programs also. Program 3, program 4. A lot of programs we'll be discussing in the coming days. Okay, to get familiar with these programs. Okay, now if you have doubt, please ask me, because there is a one test I have to take for you people. Is there any doubt, guys? I know it might have been a little bit faster, but anyways, we'll take care of this. Any doubts? Any doubts?
No, sir.
Hope you understood the concept of automata, transition state, transition function. Okay, accepting states, final, non-final, initial states. That is what very important for this. And I hope you have understood with using this whiteboard concept. So you people might have got one link to solve your test. One classwork is been given with the weekly quiz. Okay, and it has been assigned for all the 68 students. I don't know, we have the strength of 76, but only 68 students have joined the group. So it is only for them. I think everybody should have to join the group. I have already informed. And now whatever we understood from this logic, from this last 3 classes, the test is being considered from that. So everybody should have to give this test, and the assessment results will be declared soon. It has only 4 questions, very simple test so that I can understand whether you understood throughout the week what classes we have taken. Okay, class. So that's for the day. I think the questions are also quite easy, and we have only 5 minutes. So before attending the another class, it's already 9:50, 10:50. By 10:55, you are supposed to submit the test. Okay, by 11 maximum. That's for the days, guys. Hope you perform well, and wish you all a happy Teachers Day. You are also a teacher for somebody, maybe your younger brother, sister, somebody else. You might have, even I might have learned some things from you people. So happy Teachers Day to all of you. Enjoy your day. Thank you, class. Thank you for the day.